Good afternoon, everyone. My name is Joe Peden, and I teach 6th grade math at South Doyle Middle School. I want to start this week's lesson by looking at the Spark Your Learning page of your packet. You'll know that you're on the correct page if you see a sea turtle in the top right corner. As you see from the title, today we're talking about how to write and evaluate numerical expressions for situations. By the end of today, you should be able to write and evaluate numerical expressions using the order of operations. So let's dive into our first problem of the day. Follow along as I read aloud. Two tour groups are visiting an aquarium. There are 20 children in one group and 22 children in the other. Along with the two group leaders, there are 5 additional adults between the two groups. If the cost per child is $9 and the total for both groups is $490, what is the cost per adult? Explain your reasoning. Now that we've read the prompt for the first time, we need to ask ourselves, what is this prompt actually asking about? Based on my first read, this prompt is focused on the cost of admission for adults to an aquarium, the cost per adult. Now I want to reread the prompt, but this time as I read, I want you to underline any quantities that you hear or see within the prompt. Follow along as I read a second time. Two tour groups are visiting an aquarium. There are 20 children in one group and 22 children in the other. Along with the two group leaders, there are 5 additional adults between the two groups. If the cost per child is $9 and the total for both groups is $490, what is the cost per adult? Explain your reasoning. As I read that problem out loud, I hope you're able to underline some of the quantities that were present. Personally, I underlined 2 tour groups, 20 children in one group, 22 children in the other group, 2 group leaders, 5 additional adults, the cost per child is $9, and last, I underlined the total for both groups is $490. This is all the information that I'm going to need to be able to solve this. To help you out, here are the things that I underlined in the question. That was quite a bit of information to have to take in all at once. So to help us out, we can organize this information by combining and consolidating our like terms. First, it stated that there were 20 children in the first group. In the second group, it said there were 22 children. With some basic addition, that tells us that there would be 42 children in total. We can also combine the number of adults to find their total. So first we had 2 group leaders. Then we had 5 additional adults acting, I guess, as chaperones. Our total for them would be 7 adults. Now that we've combined the like terms to get our totals, we can return to our prompt in question. If the cost per child is $9 and the total cost for both groups is $490, what is the cost per adult? To solve for the cost per adult, our first step is to determine the cost for each child. Since each child was $9, we can use some quick multiplication to find the total cost for just the children. First, I'm going to multiply my 42 times $9. Carry the 1. 4 times 9 is 36, plus 1 is 37. So that means that just for the kids, it would cost $378. We're now going to take this $378 and we're going to subtract it from our original total. By subtracting the 378 from the 490, we're going to be left with what the cost for the adults was. I am going to have to borrow from the 9 to do my subtraction. That becomes a 10. So the cost for the adults was $112. However, our task is not asking us what was the total cost spent on adults. It's asking us what was the cost per adult. So in order to figure that out, I'm going to have to divide this 112 by the number of adults that were on the trip. So I'm going to need to do 112 divided by 7. Seven can go into a group of 1. It's worth 0. Subtract, bring down the next 1. 11 divided by 7 is 1. 1 times 7 is 7. Subtract, that's 4. Bring down the last group, which is a 2. 42 divided by 7 is 6. 6 times 7 is 42. So we don't have a remainder. This 16 is our ticket price for the adults. So an adult ticket would equal $16. Now before we go on to our performance tasks, I want to quickly look at the turn and talk at the bottom of the page. Let me get some more room on my whiteboard. Turn and talk. If the aquarium gave both groups a 10% discount, what would the total cost be? Explain. According to our turn and talk, we're now going to be given a 10% discount from the rate that we found or that we used earlier. So we're going to find a 10% discount of $490. Now before we do that, we need to remember that 10% is the same as saying 1/10 of the total cost of $490. So once I find out what that 1/10 equals, I can subtract it from that 490 and I have my new rate. To find out the value of that 10%, I can just do some real quick multiplication. Here, I'm going to multiply $490 times 1/10. Before I can do that, they need to be in fraction form. This gives me a new value of 490 over 10. That's going to simplify to $49. So that's the amount of money that they're going to discount from the original price. So to figure out our new cost, we're going to have to subtract the two. 490 minus 49. So I'm going to borrow, do some quick subtraction, and I get that my new cost would be $441. We've now completed our Spark Your Learning page. So we're going to move on to our Unit 4, Equivalent Expressions, Performance Task page. Remember, our learning goal is to write and evaluate numerical expressions using the order of operations. Today, I'd like to solve questions 1 and 2 with you, but I'm also going to include my answer key for all the problems on this page at the end of the video so that you can check your work with mine. Unit 4, Equivalent Expressions, Performance Task. Question 1. Darla is creating a family tree. She starts by writing down the names of her 2 parents. For each of her parents, she writes down the name of their 2 parents, and so on. After 6 generations, how many names has she written down, not including herself? Write and evaluate an expression using an exponent to find out. This is our task. To show that we are successful, we not only have to write this expression using an exponent, but we're also going to have to evaluate it correctly. So to help me out, I went ahead and started drawing a diagram that allowed me to start to see the pattern so I could figure out what exactly is going on in this prompt. So here's Darla, and here are her 2 parents. So that's that first generation. So there's 2 parents there. If they each have 2 parents, in the second generation, there's 4. Now, if each of those parents had 2 of their own parents, by the 3rd generation, we're looking at 8 additional parents. For the 4th generation, we'd be at 16. Now, I could have kept drawing this pattern, but honestly, it would have gotten so smashed together that it wouldn't have been legible. But already we can begin to see the pattern. We have 2, 4, 8, 16. So that means in the 5th generation, we should have 32 parents. And then in the sixth generation, that would have 64. So already, I hope you can begin to see what's going on with this pattern. Based on my drawing, I notice that the number of parents is doubling every generation. So this gives me my base for my exponent, my 2. That's the number that we're multiplying over and over again by itself. So that means by the sixth generation, we could also write it as 2 to the 6th power, which would represent 2 times 2 times 2 times 2 times 2 times 2. The prompt wasn't asking us, though, just to find out how many parents would be in this sixth generation. It's asking for how many would be their total. So to figure that out, we're going to have to figure out all of the parents in each generation and then combine them with addition. So first, let's see how many would be in our first generation. Well, that'd be 2 to the 1st power, which just equals 2. I know that because I also drew 2 p's right there. Next, 2 to the 2nd power, 2 times 2 is 4. Third generation would be 2 to the 3rd, we're up to 8. 2 to the 4th, take the 8, multiply by 2, and we're at 16. 2 to the 5th gets us to 32. And then 2 to the 6th, we're back at that 64 people that I mentioned earlier. To find the total, we're going to have to add all of those together. So 2 plus 4 is 6, plus 8 is 14, 14 plus 16 is 30, 30 plus 32 is 62, and finally 64 plus 62 gives us a total of 126 parents. Question 2. Darla wants to draw her family tree on a rectangular piece of paper. She has a large piece of paper that is 400 square inches. 2A. Write the prime factorization of 400. 2A. We need to find the prime factorization of 400. Remember, prime factorization is finding which prime number multiplies together to make your original number. So to do this, I'm going to use a factor tree on my whiteboard. I'm going to start with 400. Now 400 is an even number, so I know it can be easily divided by the prime number 2. 400 divided by 2 is 200. Now I'm done with this 2 because it's a prime, so I'm going to look at the 200. 200 is another even number, so I can just keep going and dividing by 2. That would give me 100. Another even number. Gives me 50. I can divide 50 by 2. And that gives me 25. Now here's the catch. I can't divide 25 by 2 to get a whole number. So instead I'm going to have to divide it by another prime number. 3 is not going to work, which is the next prime number, but 5 would. 25 divided by 5 gives me 5. Now the thing is, I can go one more step because I can divide that 5 one more time. And there's my prime factorization tree. That includes all the prime factors for 400. Question 2b. List all the possible whole number lengths and widths of a piece of paper that has an area of 400 square inches. Now before you solve this problem, you need to remember that area is length times width. Now to actually solve this, I'm going to use them. Now before you solve this problem, you need to know that area is length times width. So to help us find all the possible whole number combinations that could give us 400 as our area, I'm going to use a factor list This way I can start with the smallest and largest combination and then work my way until they meet in the middle. And that way I know I've not only covered all my factors, but it also gives me a nice organized view of it. So start with 1 times 400. 1's going to go on that side, 400 on the far side. Next would be 2 times 200. 4 times 100. 5 times 80. 8 times 50. 10 times 40. 16 times 25. And then finally, 20 times 20. But because that's the same number, I only have to write it one time. Here are all the possible factors or combinations to make that 400. From this list, I can now write out all the possible combinations for my answer to 2B. I'm going to start with a 1 by 400. Then 2 by 200. 4 by 100. 5 by 80. 10 by 40. 16 by 25. And my last option was a 20 by 20. Those are all the combinations that you could use to make 400 using whole numbers. Question 2C. Which length and width would be best for Darla's project? Why? Now this problem is an opinion-based problem, but there are some answers that are going to be considered more appropriate than others. If I were to look at my choices from 2B, I would probably choose options that were near the middle of the group for me. Personally, I like the 16 by 25 option. I think visually it's going to give us the most room in order to write out all 6 generations and all the names. Remember, as we were talking about earlier, it's going to take 64 names just by the time we get to that 6th generation. So in our paper, we're going to have enough room to write all 6 levels and going all the way to 64 names wide. If we use something like a 1 by 400, that's simply going to be too narrow. If we use something like a 10 by 40, we may have more than enough length with the 40 inches, but I don't think the width is going to be great enough. So personally for me, I think that the best way for her, go with that 16 by 25 inch choice. Now, we finished questions 1 and 2. I want you to go ahead and try questions 3 and 4. While they're not exactly the same steps or the same problems that I've already covered for you, they are going to help us reach our learning goal today. Our goal is that by the end of today, you should be able to write and evaluate expressions using the order of operations. So remember that as you're going through and solving these problems. I just want to go ahead and thank y'all for joining me for today's lesson. If you wish, there is going to be an answer key at the end of my video. So after you answer questions 3 and 4, go ahead and compare your work to mine and make sure it matches up. If you're willing to do that, just go ahead and pause the video now, and by the time you restart it, the next section will just be the answer key. Thank you again. Stay happy, stay safe, and stay healthy. All the best.